what we did last lesson, I'm going to show you a little bit more about some balancing puzzles. I'm going to show you some different ways you can do different types, teach you some of the basic rules, and then give you a couple of hints to help you solve some of these. So as you can see from my little example here, I've just tried to give you a little bit of a kind of starting point. So a balancing puzzle consists of a few different parts. First of all, we've got something at the top. In this case, a triangle. It won't always be a triangle. And that there gives you the total. Then we have different branches. So anytime you see a branch that looks like this, that's like flat, like that, that's a balanced part. So see these bits here that I've highlighted in yellow? That's saying that the left-hand side and the right-hand side of this are the same thing. So whatever this one here is the same as whatever this bit here is in total. But in terms of that, that means that all of this here adds up to the same as all of this here. So those two values here go together to make the same as this one here. Now, anytime we see something flat like this, it means they're the same. So again, we can see we've got a flat arm here. That tells you that these two here must be the same. So this one here is 5. It goes up, flat, and down, which means this one here must also be 5, because it's a balancing puzzle. Balance as in the same. Think about a set of scales in the kitchen, or you've seen them on TV. Okay, one side heavier, the other side heavier, two the same, the scales are flat. So on the right-hand side in this one, okay, we're just going to look at this one in a bit more detail, we can see that these two here must be the same, because they're both on a horizontal flat piece. So these two here are both the same. We add those together because both of them are on the right-hand side. 5 plus 5 is equal to 10. If 5 and 5 makes 10, that means over here the left-hand side must be 10. And there's only one thing here, so that one there must be 10. And all together they make 20. And that is a basic example of a balancing puzzle. Balance because it's the same on left and right as long as they're flat, and each side adds up to the same altogether. Let's try a couple of these together and see if we can check we understand the rules. So here's another one. Now here we've got two circles hanging down along one branch. When we've got two things hanging straight down, okay, it means that we add them together as we go up. So 3 and 4, that means that together on that left-hand side adds up to 7. And as we can see on the other side, we've got this one here, which also adds up to 7. They are balanced. 7 and 7 together makes 14, which means over here must be 14 because they're balanced. 14 and 14, we add those together to make the total. So the total must be 28. Finally, we can see on this side here, let's make it a blue. We've got 14. If we combine these two here, we've got 7, and we need another 7 because 7 and 7 makes 14. And now we've solved the puzzle. Now sometimes students get confused when they see ones that look like this one on the left. As you can see, first of all, these two are balanced here, these two are balanced here, and these two are balanced here. We know that on the left of the left, that one there is 20. As we can see from that blue line, it's balanced, which means this one here must add up to 20. What that means is that all together, different colours, do it pink, if this 8 and both of these two here, they add up to 20 altogether. So we're saying 8 here plus these two is 20. And we know that these two must be the same. So it's a bit messy there, let's just tidy it up a bit. So we know that, let's call this A, these two A. because we don't know what they are. So I can say, well, I know that 8 plus A plus A, and they're both the same because they're balanced, is equal to 20. So then I think, okay, a number that I can times by 2. So I can say, well, 8 plus 2 lots of A is 20. And I think, ooh, okay. I could say, okay, well, why don't I know that 8 plus 12 makes 20. So I know that 2 times something must be 12 because 12 plus 8 is 20. So then I think, 2 times 6 is 12. So A must be 6. 20 and 20 together make 40. So I know this one has to be 40. And then I know that to get these ones here, well, it's 40 split into 2. So I could say, well, I know that 40 divided by 2 is 20. So these two here must be 20. So we're starting to bring that in. And finally, 40 and 40 together makes 80. So it's all about just balancing and starting to use our adding, subtracting, multiplying, dividing. And as you can see, what we started to do here is start to think about it in a problem-solving way. And what might be helpful for you on some of the more complex ones is thinking about it by using letters to help you remember which bit you're referring to. Our puzzles, like I said, sometimes using the letters can be helpful for us when we're solving the more complex puzzles. So we're just going to have a look at these ones here. Now, the difference you'll see between this one and the previous one is we have some slightly ones that look like this. And what that tells us is that these are not balanced. So previously, if you look at the one I've highlighted in green here, they've been flat, and that means the left and the right are the same. The ones in yellow are where we've got it unbalanced. So we'll start off with this one over here. And we can see that what that says is the 4 is up high and the E and F are down low. So think about a set of scales. If two things are the same weight, they're balanced. If you're on a seesaw or on a set of scales, if one thing's heavier than the other, this one goes down, this one goes up. Think of it like a seesaw. Okay, if the heavier person sits on this side, it looks like that, it's unbalanced. So same weight, they balance. So that 4 is here, the E and F are down here, which means the E and F must weigh more than 4. Because E and F are flat, we can say that E and F, however, are the same. So first thing we can do is say, well, we don't need E and F. We can just think of this as E and another E, because they must be the same. So this is 4, this is something. But we know that E and E, the two E's we've got on the left, must be more than 4. And that little symbol there means more than. So 2 E's are more than 4. Remember, we're looking for the smallest value. So we're thinking, okay, 2 times table, what's the smallest number? Well, if E was 2, well, 2 times 2 is 4, but so that's not going to work, so we need it to be bigger. So the next one is 2 times 3 is 6. So 6 is bigger than 4. That tells us that these must be 3. 3 plus 3 is 6. And now we can see that if we put a 6 here, that 6 is bigger than the 4. 6 is bigger than 4. But together, the 6 and the 4 make 10 altogether. We can then bring that 10 over to here, which means we know that that one is that's flat, so those two are balanced, and those together are going to go to make A. So A is 10 plus 10. A is 20. So we can replace that with 20. As we've done before, we take this 10 here, we can split it in two to 2 balanced 5s. And D is the only thing there, so that one's a nice easy 5. Looking at this last part here, so we've just got this bit here to do. Well, we can see that the C is up high. So the C here is higher than the 3, which means it must be lighter. So we can say that C is less than 3. So C can be 2 or 1, but we don't know which one yet. If we think of it as 2, well, if it was 2, then 3, that would make, this one was 2, And those two together, 3 and 2 would make 5. Well, we know the total's got to be 5, so it can't be 2. So we can rule that one out. So we know that, therefore, it must be 1. If it's 1 here, we've got 3 and 1. 3 plus 1 is 4. So we're saying 3 plus 1 plus b is 5 at the top. So we know we only need one more. 3 plus 1 is 4, plus 1 is 5, b is 1. And so to summarise what that looks like, it will finish off looking something like this. We can see that 1 is less than 3, which is why it's like that. 4 is less than the 6, so the 6 is lower because it's pulling it down. The 10 and the 10 make 20. And obviously we've got 2 5s here because they're balanced. And all the numbers add up. So that's how we can do it using these sort of puzzles. Sometimes you can see the unbalanced or flat is balanced, and we can use that sort of working out to help us. What about ones, the other type of balancing puzzle you'll see is where we've got different shapes, and all you've got to do is figure out what different shape is worth what. And I'm going to go through 3 different examples with you, like a starter, a middle, and a more complex one. So here's a sample one here. Sorry it's a bit blurry, it's because it's been scanned in with a bit of paper. So first thing here is it gives you, these type of puzzles often give you a little clue at the bottom. And we can see here, the first clue it gives you is it tells you the total is 16, so we can put that 16 at the top. As we've done many times already so far in this video, we can just do a little split where we split it in half. 16 split in half means we've got 8 and 8 on the left and the right. And straight away we can see the left-hand side is 8. So that little circle is 8. We could have written it, if we were writing our answer, we could have written circle. You can do the shading if you want, with little lines. We'd say circle is 8. Next thing we can do is we can take this 8 and we can do our split again. Split 8 into 2 equal parts, 4 and 4. And that helps us over here because now we can see the triangle with the wavy lines is 4. And finally we can split again. 4 split in half is 2 and 2. So the rectangles must be 2. So there is a straightforward example of these different puzzles. And so what would the solution look like? Well, we'd have 16 at the top, 8 here, 2, 2 and 4. And remember to check, you don't need to write this down, but you can do this mentally. If you add up all the weights, they should add up to the total. And we can see that's true here. Okay, let's look at a slightly more difficult example now. Just going to move this down a bit. Got a little space. Ooh. There you go. So first clue it gives us is the little total here, so we can pop that in at the top, 24. Everything adds up to 24. And we're going to come back to the second clue in a minute. So as always, we can split to get ourselves started, 12 and 12. We can split again to say 12 split in 2 is 6 and 6, and that nice and quickly gives us that the triangle is 6. Now on the left hand side, this bit here, let's just show you what I'm talking about, this bit here, we can now see they're going straight down. We've talked about these before. So that means that the oval at the bottom and the rectangle together are going to make 12. But we also, to help us, have this little clue at the bottom. The triangle minus circle, or oval, sorry, or ellipse equals 2. If you want to help yourself, you can maybe just use letters, T for triangle, E for ellipse. This is T, this would be R for rectangle, and E. Sometimes this can help you. Well, we now know from before that the triangle is 6, so we're saying 6 minus something is 2. And hopefully we can all do a little bit of mental maths and say, well, 6 minus 4 is 2, so that must mean that this ellipse here is 4. And then we need 8 more to make 12. So we can say the triangle is 6, the rectangle is 8, and the ellipse is 4. Last one then. Now this one is a more complex one, and this is getting onto your kind of mastery / exemplary end of the spectrum. We've got 3 clues here. We're going to do them one at a time. First one, as always try and start with your total. You might not always get given the total, but if you do, it's a great place to start. Now here's where you've got to think a bit more carefully about your diagram. Think about this line at the top. It's got 3 parts coming off, so it's slightly different to ones you've seen so far. Think of that line at the top as like this pencil. It's got 3 bits, one on the left, one on the right, and one in the middle. And you see I'm holding it in the middle, and it's balanced at the moment. If we put a weight on the left-hand side, it shifts it, like the example we saw before. Put a weight on the right-hand side, it shifts it. But if you put a weight in the middle, it doesn't make it go left or right. It just stays as it is. It's the same with our diagram here. This bit that I've highlighted yellow here, okay, that's going down. It adds to the 31, but it doesn't make it go left and right. So if we think about it as 3 points, it's small pencil, A, B, and C. Just going to zoom right in on those. Okay, A, B, and C. Well, we know that A is equal to C, but B doesn't necessarily have to be equal to C, and B doesn't necessarily have to be equal to A. It can be anything you want, but we do know that A and C have to be the same. So this one's going to take a little bit more problem solving to get done. So let's start off with what we do know. It tells us, let's use our letters. This is going to be really helpful for us here. Let's say these ones are E for ellipse. Let's call this one R for rectangle. Let's call it D for diamond. No, not R. S for square. And T for triangle. So here we can see that the 2 triangles add up to this point in the square. And the square is equal, therefore, to 2 triangles. And at the top here, we've got a square and 2 triangles worth of weight. On the left-hand side, we can see that all together, because that's all one big thing here, that we have to add together 2 ellipses and a rectangle. And this in the middle is just a diamond. So that 31 is equal to everything put together. 2 ellipses and the rectangle on the left, the diamond in the middle, and the square and the 2 triangles on the right. Now we can start to get our clues involved. And we're going to start off with this second clue here. It tells us that 4 of the ovals or ellipses make one rectangle. So we can start to add that information in. We know that 4 of these make one of these. So this rectangle is actually worth 4 of the ovals at the bottom or ellipses. So that means we could think about it as 4 ellipses and another 5th and a 6th. Instead of saying 2 ellipses in a rectangle, we could say, well, I've got 6 ellipses on the left. And we know that's the same on the right-hand side because those 2 have to be balanced. So now we can say that 4 of them make a rectangle, and that means you've got 2 at the bottom and a rectangle, 6 and 6 on each side, and a diamond. So we could think of this 31 in a different way. We could now say, well, we know 31 is equal to the 6 here and the 6 here, 12 all together, and whatever that diamond's worth. So already we're starting to narrow things down. We can also look at this little clue here. It tells us that the rectangle minus 1 is equal to the diamond. The diamond is 1 bigger than the rectangle. So we can take that information and add it to our diagram here, or here. We can say, well, we know that diamond is now worth a rectangle minus 1. We also know the rectangle is worth 4 ellipses. So we can say it's 4 e's minus 1. So we've got 12 e's and 4 e's, we've got 16 e's altogether, minus that 1, and that makes 31. So we know that 31 is the same as 16 ellipses, but 1 less. So we can add, let's say, okay, well, if we added 1 to both sides, what would we get? Well, we'd say 32 must be worth 16 ellipses, because 32 minus 1 is 31. So if 16 of something, if you go to a shop and you buy 16 of something and the cost is $32, that means that one of them must be $2 each. So we can add that information because all that's very complex. But what we can do is say, okay, let's just clarify it now. Let's just get rid of all this extra stuff here and just keep that one bit of information we now know. Ooh. There. So we have E is 2. So this is worth 2, this is worth 2, and the total is 31. We know that the ellipse is worth 2, so 4 times 2 is 8, so we now know the rectangle is worth 8. 8 plus 2 plus 2, we add those together to get 12, and we know this one here must be 12. We can then split that into 2, 6 and 6, and we can say, oh, that one must be worth 6. Split it again, 3 and 3, and this is 3 each. Finally, we know that the rectangle now is 8, and 8 minus 1 is 7, so that one there must be 7. 12, 12 and 7 makes 31. So we can see these two are balanced, but we need the 7 to go to 31. Now remember, that's a complex example, not expecting everyone to be able to get to that point today, but that's where we're headed. And we can see that it takes a bit of problem solving to figure out, but using the letters can be really helpful. So that's enough of me talking at you. Remember, we started some of these yesterday, so you can, if you do finish today, you can practice some of the more complex ones. As you can see, there's 144 to do. I don't expect you to do all of them, don't worry. They do get harder as they go along. These are the same idea. You've got different shapes, and you're trying to figure out what each one is. So this one, for example, just a very quick example, split it into two 24s, 24 split into these two here. It's going to make them 12 each, which is why that's 12. 24 split in half, 12 and 12. Split it into 2, 6 each. Split it into 3, 4 each. And that would be a quick walkthrough of that one. So, give these a go. They get more complex as they go along. You will have to do a bit of problem solving. You are going to get a little stuck at points. That's good. That means you're challenging yourself. And feel free to collaborate with some of the other students in the class. And you can maybe share screens and work together. I'm more than happy for you to do that as you're working through these today. Give them a go, enjoy them, and let's see how it goes.